Welcome to Daily Papers.
Okay, I have a quick question for you. Let's say I tell you there was an accident on the highway. Now, on a scale from 0 to 100, how likely is it that traffic was worse than usual?
Pretty likely, I'd say. Maybe an 85 or a 90? It's not 100% because maybe the accident was cleared really fast or it happened at 3 a.m. when no one was around, but it's a good bet.
Exactly. You didn't just give a yes or no answer. You weighed the possibilities and came up with a probability. That kind of thinking, which we do all day, every day, is called probabilistic reasoning, and it's at the heart of a fascinating new paper called Humans and LLMs Diverge on Probabilistic Inferences.
LLMs, of course, being large language models, the AI technology that powers tools like ChatGPT. We know they're great at tasks with clear right and wrong answers, like solving a math problem or writing code. But this paper asks a different question. How do they handle the messy, maybe-filled reasoning that makes up so much of human life?
To figure this out, the researchers had to create a special test. They couldn't just use standard logic puzzles. So they built a new dataset called ProbCopa, which is essentially a list of 210 of these what's the likelihood scenarios.
They're simple cause and effect statements. For example, they'd present a situation or a premise like a drought occurred in the region, and then a possible effect or hypothesis like the crops perished.
And the task for both humans and AIs was to rate how likely that effect is, given the situation, on a scale from 0 to 100. So for the drought example, you'd probably rate the crops perished as highly likely. But what if the possible effect was the water became contaminated?
That's less likely. It could happen, maybe indirectly, but it's not the first thing that comes to mind. I'd give that a much lower score, maybe a 20 or 30. It's not impossible, but it's not a sure thing either.
And that's the whole point. There's a huge gray area. The researchers got about 30 different people to rate each one of these 210 statements. And when they looked at all the human answers together, they found something really interesting.
Let me guess. We don't all agree?
We definitely don't all agree, but it's more structured than that. If you plot all the thousands of human responses on a graph, you see three distinct clumps. There's a big pile of scores down at the highly unlikely end, another big pile at the highly likely end, and a third very significant pile right in the middle.
The 50-50 pile. So we're comfortable with saying something is very likely, very unlikely, or just plain uncertain. The technical term for this, for anyone curious, is a trimodal distribution. 3 modes, 3 main clumps.
Exactly. And another neat finding about the humans was that for the scenarios where our answers were the most spread out, the ones we disagreed on the most, we also took the longest to respond.
Which makes total sense. Those are the real head-scratchers. You have to stop and think about it more. It shows that our uncertainty isn't just random noise. It's a genuinely tricky problem.
So that's the human baseline. Nuanced, comfortable with uncertainty, and showing a wide range of opinions. Now for the big comparison. The researchers took this exact same test and gave it to 8 of the world's top AI reasoning models.
And to capture their range of opinions, they didn't just ask each question once, they asked each AI to rate every scenario 30 separate times. So how did our AI counterparts do?
They were very different. The single biggest takeaway is that large language models are overconfident. They almost never use the middle of the scale. When the researchers plotted the AI's answers on a graph, they didn't get that 3-clump pattern. They got a 2-clump pattern.
So no 50-50 pile for the AIs.
Nope, just a huge pile of answers at the definitely not end and another huge pile at the definitely yes end. The AIs basically hate saying maybe. They're strongly biased towards giving extreme black and white answers. It's like if you asked the AI about the highway accident, it would be much more likely to just say 100 or 0 without considering the nuance.
It's like the AI is always shouting yes or no, while humans are often just shrugging and saying, it depends.
That's a perfect way to put it. And there was another major difference. The AIs showed far less variation in their answers than humans did. For any given question, the 30 responses from an AI would be clustered very tightly together. Humans, on the other hand, had a much wider spread of scores, reflecting a genuine diversity of opinion and background knowledge.
So where the AI gives one confident answer, you might get 30 people giving a whole range of reasonable, slightly different answers. That's a pretty big gap. Does this mean the AIs are just bad at this?
Not necessarily. The paper shows that when a situation was obvious, when all the human raters agreed that something was, say, a 95 out of 100, the AIs usually agreed too. The divergence, the disagreement, happens in that messy middle. When humans are uncertain, that's when the AI's tendency to give an extreme confident answer makes them look very unhuman.
The researchers also looked under the hood a little bit, didn't they? They analyzed the AI's chain of thought, which is kind of like its internal monologue as it works through a problem.
They did, and they found that for the really tough questions, the ones that humans found most ambiguous, the AIs tended to think for longer. Their reasoning chains were longer, as if they were turning the problem over and considering more angles.
That's fascinating. So in a way, both humans and AI spend more cognitive energy on the hard problems. The difference is the final answer we produce. We end up expressing that difficulty as uncertainty, giving a middle-of-the-road score. The AI, on the other hand, seems to resolve all that thinking into one final, confident answer.
And that's the crux of it. The paper concludes that there's this persistent difference between human and AI reasoning when it comes to uncertainty. The models are trained to be helpful and provide definitive answers, which might make them shy away from expressing the kind of nuanced, probabilistic judgment that we humans use to navigate the world.
It really underscores that even as these models get incredibly powerful, their way of thinking can be fundamentally different from our own. And if we want to build AIs that can truly partner with us in our complex, messy world, they'll need to learn the value of a good, honest maybe.